that drum solo. Wish I knew how to play the drum.
I'm breaking rocks in the hot sun. I fought the law and the law won. I fought the law and the law won.
Okay, that's where we'll start. Alrighty. So we're going to talk about the mean value theorem. I'm going to underline these two ideas. That's continuous and differentiable. Okay, we already looked at a problem that wasn't differentiable, right? And did I come up with an equation like this? F of x equals, what was it? X squared minus 3x minus 4. And I gave you an interval. Did I say it was 0, 4?
Yep.
Okay. So I figured out f of 0. And what did I get? Negative 4. Is that right? So 1, 2, 3, 4 right here. And f of 4. Did I get 0? 1, 2, 3, 4. It's a parabola, correct? So it's got a vertex, correct? So to figure out that vertex, I can take the derivative and set it equal to 0. Does that sound reasonable? And the derivative is 2x minus 3. Make it equal to 0. And I got 1.5 is equal to x. So that's a critical number, isn't it? Okay, so I'm going to put that critical number into f. And did I come up with a negative 6.25? Okay, so that's about right here. So the graph looks like this. Would you agree? And I can create a secant line right here by connecting those 2 points. I can figure out the slope of that secant line by taking f of 4 minus f of 0 over 4 minus 0. And I get 0. What do I get here? Minus a negative 4. Does that look right? Over 4 minus 0. And I get 1. So that secant line has a slope of 1. So since this f of x is continuous and differentiable, why? I think I spelled it wrong. How do I know that? Yes, sir.
First, you were able to compute take the derivative of the first equation, and also there's no asymptote.
That is true, but how could I simply look at that and say it's differentiable without doing any work at all? Right. It's a polynomial. Alrighty, so that must mean that I can get a different colored pen and I can create a tangent line. Let's see if I can create it. A tangent line that's also parallel, right? And there's a point here, C, comma, f of c, where c is between these two numbers, 4 and 0. I'm guaranteed to have that the average rate of this line is equal to the instantaneous rate of this line. There has to be a moment between 0 and 4 where I'm going 1. How could I figure out what that c is? I know it's not 19, correct? I know it's not a negative 3, correct? Yes, sir. Now notice how I do this. I say 2c because I'm solving for 2c. Right? That's my derivative with c in it. Would you agree with that? And I'm going to make it equal to 1. Why do I choose 1? Well, that's the slope of my secant line. That's the slope that I want for my tangent line, right? So I get 2c is equal to 4. C is equal to 2. So this point is got to be 2 comma, oh, let's see. If I put 2 in here, I'd have 4 minus 6 minus 4. I think I get a negative 6. So that's my vertex, isn't it? Or, excuse me, that's wrong. That is not my vertex. Saying it is my vertex is wrong. It's simply the spot on the function where the tangent line is parallel to the secant line. It's simply the location where the tangent line is parallel to the secant line. Okay. Took the slope of the secant. The slope of the tangent line is equal to 1. Anything I need to clear up? Anything I need to do better at? Math geekness. You don't go and tell stories about tangent lines and secant lines. What you do is you tell stories when you got picked up by the law. Last year I got picked up by the law. I was doing a math problem. I actually tweeted this out. And I got in a little trouble with my wife. So the way I live by North Junior High, I hop on Highway 15. I go north. I turn off on County Road 29 by the Holiday Station, the Quick Trip, and all that type of stuff. And now Casey's. Come here on Mayhew Lake Road. Got my path? Well, there's a stoplight on that there. And McDonald's is to my left. And Walmart's to my right. You know what I'm talking about? So I'm traveling. And I'm doing a calculus problem. And all of a sudden I look in my rearview mirror. Well, first of all, I hear sirens. So I go, oh my gosh, there must be a car accident towards Rice. And I look in my rearview mirror, and I do see a highway patrol lights are flashing, siren blowing, and he's pulling up behind me. So I pull over. And he comes out, and he right away shines a flashlight all over my inside of my pickup. He's looking for my phone. I keep my phone. I don't even know where my phone is if my wife would call me. Okay, somewhere in my coat pocket somewhere. Okay, and then he looks at me and he starts flashing the eyes like saying this guy must be impeded by some type of ingestion. And I'm confused. One, I'm confused because one, I didn't solve my calc problem. And secondly, he's interrupting me solving my calc problem. And he said, did you know you ran a red light? And I go, oh my gosh, I could have killed somebody. I felt really bad. And I didn't want to tell him I didn't even see the red light. And I said, no, I didn't, officer. I'm always very kind because it's always my mistake. I mean, what am I going to argue about? Okay. And he said, did you see me alongside of you? He said, what would be the reason for that? Well, I didn't want to tell him I was doing a math problem. And so I said, I don't know, officer. And he starts talking to me like I'm elderly, which was my first really weird experience of that. And I said, he says, well, you stopped. I was to your right. And so I was between the turn lane and the right lane. And we finally figured out that the left turn signal turned green. And because no one was coming, I decided to go. Okay. So I tweet that out. I said, don't do calculus and drive at the same time. And then later on, I got the bill, $140. So I tweeted out, cost of doing math and driving, $140. Okay. I don't think anything of it, and I forget to tell my wife. So the entire abyss knows this, except for my wife, because she doesn't like dealing anything with the internet. So I've got to do all our internet stuff. Okay? Pardon? Oh, she knows now because she went to a Super Bowl party, which is like a month later. And I have friends that follow me on Twitter, and they tell her, and I'm not there because I'm sick. And they think I'm tweeting as I'm driving. I don't tweet and drive. I do math and drive. God, can you imagine if I was trying to tweet and do math and drive at the same time? I'd be dead. And so we're driving somewhere, and she says, oh, I got a math problem for you. I go, oh my God, I love you even more. We're going to do a math problem together. I got all excited. She says, what is? Okay, what was the problem? 35 times 4. 140. She says, yeah, $140 for tweeting? I said, I wasn't tweeting. Well, everybody says you were. I said, no, I tweeted that later. Well, what were you doing? A math problem. That does not help in the argument. So anyway, that's my first story with the law. And the second story has to deal with this. I wish she would have taken my cell phone away from me. But no, she didn't. Because it's more important to her to keep track of me. Because without the cell phone, there's no tracking device anymore. Okay. We were married 20 years, and now I'm being tracked. Okay. All right, so there's a little town. When I drive to Plainview, I go by a little town. I drive down Highway 52, and there's a little town called Cannon Falls. So I drove by a highway patrol going 60 miles per hour. Well, within the speed limit, mind you. And 3 minutes later, I go by the second highway patrol. You've seen that happen, haven't you? It's like, especially on holiday season, they're like planted every few miles, okay? Especially on 52, because it's a high speeding area. And I'm going 57. I'm even going slower. However, I got pulled over. And I got ticketed for exceeding the speed limit of 65 miles per hour. I agree with you. Why would I be ticketed? So, we're going to use the mean value theorem. The first thing I need to know is average rate. Well, first of all, Kruger is traveling in a continuous and differentiable manner. It can only work if it's continuous and differentiable. The only time it can work. So my average rate, well, I need what? To figure out average rate, you need exactly what? 2 points. So I'm going to have time, and I have distance. Because I know distance divided by time gives me my speed. Would you agree? Right? So when I passed the first patrolman, that's when everything started. So that's 0, 0. What is it for the second patrol car? I need a distance. 4 miles. I need a time. Yeah, 3 minutes. But there's something wrong with 3 minutes. You know what's wrong with 3 minutes? If I take 4 and divide it by 3, I get 1 mile per minute. And I want mph. So I'm not going to use 3 minutes. Okay, so there's 60 minutes an hour, right? 30 minutes and a half hour, correct? 1/20th of an hour. How'd you get that?
Well, you just take 3 divided by 60.
We got 1/20th. Okay? So now I'm going to use my slope formula. Would you agree? 4 minus 0 miles over 1/20th, right? There's my 3 minutes over 0 hours. What is that? 80 what? 80 miles per hour. That's my average rate. My average rate is 80 miles per hour. So, what happened? I see a highway patrol. I brake like everybody else. I look and see that highway patrolman in my rear view mirror. You know what I do? I step on it and I'm flying. Guess what I see? Another highway patrol. What do? I brake and start. Well, I used to pray. Now I do math proofs. Okay? That has not helped. Okay? So, because I'm traveling in a continuous and differential manner, and my average rate is 80 miles per hour, since my average rate is 80 miles per hour, there must be a time t. Where is that time t in? Was I driving 80 miles per hour the whole time? Well, within what? 0 to what? 0 to 3. You know why 3? Because it's 3 minutes. It's time. Yep. 0 to 3. There must be a time t in 0 to 3 where I was driving Got better? 80 miles per hour. And that exceeds the speed limit, doesn't it? Okay. Continuous, differentiable. Average rate. So I probably, if I would graph it, it'd probably look like this. Here's 80. Well, that's a lousy tangent line. There's my tangent line that's parallel to it, correct? In fact, I've had other students that say, oh, Kruger, based on your drawing, at some time you had to be going faster than 80. That's probably true. Alrighty, does that make sense? That's a quiz question. These are all differentiable within their, your hands up in the air? Yep.
Was that like an actual story?
Yep. Yep.
Did they explain it to you in calculus?
I made a calculus problem out of the experience. Anything that happens to me currently, well, probably in the last 35 years, I try to explain mathematically. Because then I can deal with it and I feel better. It does not help to explain my wife in that manner, though. It's a lot easier, and I'm giving all you guys a hint. Just say, I was wrong. And I'm sorry. And wait till it happens to her. Like when the kids come home and say, oh my God, Mom got a ticket for speeding on Division Street. Shh, I told you to be quiet. That's the worst thing. Don't tell your children to keep a secret because they won't. These are always differentiable if f is differentiable, which means I can take a derivative, then it is continuous. And these are all, you could say it's differentiable because it's a polynomial. It's differentiable because it's a rational. It's differentiable because it's a radical. It's differentiable because it's a trig. And it's always within their domains because obviously this has a value that cannot be inputted, right? This has values that cannot be inputted. Domains are only those values that can be inputted. Are we okay with that? Backside. Rolle's theorem is simply a special case of the mean value theorem. It looks like this, or looks like this. It's where these endpoints, the y values are the same. So the tangent line is also going to be horizontal, because when the y values are the same, you have horizontal lines. You have to demonstrate three things. One, that the function is differentiable. Two, that the function is continuous. And that f of a equals f of b. So I'm given this. This is f of x equals x squared minus 2x with that within that interval. F of x is differentiable. Since it is a what? Bingo. I love polynomials. F of x is continuous since it is differentiable. So I got to plug in f of a. So a is 0. What's f of 0? I'm going to plug in 2, because that's b, isn't it? What's f of 2? 0. So did I show that they're the same? Therefore, there should be f of c equals 0. Where c is between 2 and 0. Can I figure out what that c is? I hope so. Can anybody tell me how to figure out what that c is? What's that little tick mark mean to do? What is the derivative?
2x.
I'm going to make it 2c minus 2. Does everybody understand why I'm going to make it c? And I better get a number between 0 and 2. And I'm going to make that number equal to what? I'm going to make it equal to 0, right? And I get c equals 1. Is 1 between 0 and 2? Yeah. What does that mean? Well, that means if I put 1 into 1 squared minus 2 times 1 into my function, I get a negative 1. That means 1 comma negative 1 is a 1 is a critical number, but not 1 comma negative 1 is not a critical number. It's a point. So what kind of point? Absolute is an absolute minimum. Let's see if that works. 0, 0, 1, 2, 0, 1, negative 1. There's my graph. Here's my closed interval. I rushed through that. I felt like I rushed through that because I wanted to make sure you had time tomorrow. Mean value theorem says this. If on an interval I have a secant line, in that interval I have a parallel tangent line. If within a period of time something has an average rate, within that time, there has to be a moment where that rate exists. In other words, if I drive to Plainview, my average rate is 55 miles per hour. I must have sometime gone, in that 3 hours, 55 miles per hour. If in 3 minutes my average rate is 80 miles per hour, that means there must have been at least one moment I was going 80 miles per hour. Is that better? Does that make sense? Now that's only if you don't have any shared points, right? Because they do ask you on the homework, okay, can you apply the mean value theorem? And you need to take a look at a graph and there's a sharp point. You can't use it. And like Emma said, your reason isn't because it's a sharp point. It's because the limit, the derivative, if you take the limit of the derivative at that value from the left, both sides, it doesn't exist. Are we all right with that? All right, I'm done.